Let us solve the exercise number 7 in the part A of data structure lab. In this exercise, we are supposed to implement queue operations using arrays. Before we write the code, let us quickly recall what are the things that we need to take care whenever we are dealing with the queue. When we talk about queue, there will be two pointers. That will be there is a front pointer that indicates which element will be deleted next, and the rear pointer which indicates which element will be inserted at this particular location. Initially, when the queue is empty, both the front and well as the rear pointer will have the value -1, indicating that the queue is completely empty. Whenever we want to add a new element into the queue, we first increment the rear pointer to point to the next location where the new elements will arrive, and we add the new element at this location. Also, whenever we are inserting the first element, in this case, this is the first element, front pointer will be pointing to the initial value that will be -1. So when it is the first element to be inserted, the front pointer also has to be moved to the next location to make it point to the first element of the array. Then onwards, whenever we want to add a new element, we will move the rear pointer by one location, and then we will insert the new values at this location. The same thing will continue. We will move the rear pointer to the next location, and we will insert the new element. This will keep on happening until the rear pointer reaches the end, or it reaches the size of the queue. When it reaches the end of the array, that is the size of the array, we will say that the queue is completely full because we have inserted all the elements. Then onwards, any more insertion, we will give an error message saying that the queue is full. What about the deletion operation? So in the deletion operation, we will move the front pointer by one location, making it virtually indicate that the first element has been eliminated from the queue. Okay, so let's first start with the insertion operation first, and then we will go to the deletion operation later. So this is the initial condition of the queue. There will be an array of size n maybe. Okay, and both the front and the rear pointer will be pointing to -1. That is the initial location. So let's start coding this part, and we will do the remaining part later. I'm going to go to the new file here. I will select the C and C++ as my file. Let me go to the next, and I'm going to call it as a QA, just indicating that this is going to be a queue of arrays. And as usual, let me include the stdio.h because I need the printf and scanf statement. Okay. Also, let me define the size of the array, and size as 5. Don't try to go beyond 5 because during the examination, inserting 5 elements itself will take a longer time. But don't just take 2 elements because your internal and the external examiner may not like that idea. After that, let's start by defining the array. I will take an integer array. Let me take the array as a, and the size of the array is as declared here, that is the 5 elements. So this will be array of size, which is nothing but array of size 5. Then I will take the front pointer. I will initialize it with the -1. As told before, both the front pointer and the rear pointer will be pointing to the -1 initially. So I'm going to take the rear pointer as a -1. Let me start the insert function. I'm going to say void insert, and I will not take any value here because I will accept the value within the function itself. The first condition is we are going to check whether the queue is full. When the queue is full, queue becomes full as you start adding new and new and new element. The rear pointer, so as you add a new element here, the rear pointer will start moving to the next. And when it reaches to the size of the array, that is the maximum element in the array. Suppose if the rear pointer is here, okay, and you know very well any more insertion is not possible. So when it reaches to the size of the array, that is the maximum element of the array, you cannot insert any more elements. So this is the condition I'm going to check here. So if rear pointer is equal to the size minus 1, the reason you know very well why we are taking size minus 1 is in C, the array index starts from 0, so the size will be 1 less than the last element. So there will be, if you notice that there will be totally 6 elements are there in this, but the last index value is 1 less than that, that is 5. So that's the reason we have taken. So if this the what is that, if the real pointer is at size minus 1, we are going to use the printf statement, and we are going to use slash n, and we are going to say q is full. Okay, so we are going to say that thing, indicating that you cannot insert any more element. Otherwise, so let's go with the otherwise case. Otherwise, we will do something. What is the something? Remember, when the first element is inserted, this is the scenario now. Both the rear and the front pointers are pointing to -1. When you insert the first element, so when it is the first element getting inserted, you move the rear pointer by one location and accept the new value. What will happen to the front pointer? Front pointer is still pointing to -1. So we have to manually move this front pointer to one step here. So if the front pointer is there at -1, this is the initial stage. That is the initial value of the front pointer. So this is the value. If the front pointer is there at -1, you just move the front pointer by one location. That is, you make it point to the 0th index value. So I'm going to code that one here. So if the front pointer is -1, I'm going to make this front pointer to point to 0. So this is just an initialization. After that, let me ask the user to enter a number. So I'm going to say slash n, and I'm going to say enter a number. So let me say that. Okay. And I will use the scanf function to read the integer number. Okay. Now this integer number has to be added to this location. So you know very well, initially both the front and rear pointer is pointing to the -1, or they have the value -1. So first increment the r by one location, make it r point to the value 0, increment r, and then accept the new value at this location. So first increment the r. How can I do that thing? So I will go to the array and I will first increment. You know very well, pre-increment is plus plus, this one, plus plus rear pointer. So what is this plus plus? You know very well. What is this I plus plus? First use the value and then increment. What is plus plus I? First increment the value of I and then use it. The same way I am using plus plus, indicating first increment the value of R. That means R was pointing to -1. This is the initial scenario. In the initial case, R was pointing to -1. So increment the R by 1, that so that R will point to the 0, and then use the value. When you insert the next element, again increment the R by 1, so that R will point to the, that is, rear pointer will point to the 1, and then accept the new value. So whatever new value user is typing, accept that new value. So this is the scenario. Let me put the semicolon over here. If you want, you can say element inserted, but I'm not going to do that thing unless I'm not going to type the printf statement. Let's look at the other scenario. So now this is the case. Remember, the front is pointing to 0. So front is pointing to 0 and R is pointing to this location. So how do you delete the element? You delete the element by making the front point to the next location. That's it. There is nothing called as a clearing this element. You just assume that when you do it virtually, it means to say that this element is eliminated. Suppose if you move the front pointer by one more location, that means the second element, first element is already gone, the second element is removed. Now again, if you think that I'm going to move it to the next location, it is not possible. Remember, there were only two elements in the queue. If you move the front pointer to the next location, that is here, that is 1. That means the first element is deleted. Okay. If you move the front pointer one more location, that means the second element is also deleted. Now you know that the queue is empty. There is nothing is there in the queue. So any more deletion is not possible. So when is this scenario? If the front crosses the rear pointer. So you notice that the front has crossed the rear value. If that is the case, then the queue is empty. You cannot delete any more element from the queue. What about the initial condition? What is this initial condition? In the initial condition, both the front and the rear pointer are having -1 value. So this is the initial case. Both the rear and the front are pointing to the -1. In this scenario also, the entire queue is empty. You cannot delete anything. So let us first code that one. I'm going to code the for deleting the element from the queue. So let me start with the void, and I'm going to say delete. Okay, so let me do that thing. Let's start with the first case. What is the first case? When the front pointer is -1, that is this scenario. If the front pointer is -1, there is nothing is there in the queue. What is the other scenario? Other scenario is when the front pointer has crossed the rear pointer. So this is the other scenario, or there is the other scenario. What is the other scenario? Front has what is this? Front pointer has crossed the rear pointer. In these cases, I'm going to say print f, and I'm going to say /n q is empty. So this is the scenario. Q is empty. So let me do that thing. So there is nothing, you can delete it. Otherwise, what is the scenario? Otherwise, you know very well, you will have to, if this is the scenario. So let's say, let's assume that this is the scenario. You have a few elements here, and you want to delete this one. You just move the front pointer to the next. So before I move the front pointer to the next location, I would like to tell the user which is the element that is getting deleted. So I'm going to first say that 45 is deleted, and then I'm going to make the front pointer point to the next element. How do I do that thing? So first I have to tell the user that let me say printf that some element is getting deleted. So let me use /n, and I'm going to say element and %d deleted. Okay, deleted. Okay, so /n, and which is the element that I'm going to delete? The element that is pointing that is pointed by the front pointer. This element is getting deleted. So I'm going to say a of a front pointer is getting deleted. After that, what I'm supposed to do is after this, I'm supposed to move the front pointer to the next location. How do I move the front pointer to the next location? Is by making plus plus. So I'm going to go here and add both of them over here. So after deleting, I will make the front pointer plus plus, indicating that it will point to the next element. So this is for the deletion. Let's go for the display. So let me say void display. This is to display all the elements of the queue. Let us look at a few scenario. The few scenario is, first scenario is when the queue is completely empty. This is the initial case when both the front and the rear pointer are pointing to the -1. If the front and if the front pointer in particular is having -1 value, that means the queue is empty. What is the other scenario? Other scenario is when the front pointer has crossed the rear pointer. So if the front pointer has crossed the rear value, that means the queue is empty. So let's code that one first. I'm going to go over here and I'm going to say if the front pointer is equal to -1, or the other scenario, front pointer has crossed the rear pointer. So if this is the scenario, there is nothing we can do because the queue is empty. In If both the front pointer and rear pointer are pointing to forget the rear pointer, if the front pointer is pointing to -1, that means the queue is empty. Or if the front pointer has crossed the rear pointer, the queue is empty. So that is what I'm typing over here. I'm going to say queue is empty, and let me use /n. Okay. Otherwise, let's look at the other scenario. Other scenario is you have few elements here. Maybe first element is deleted, and you have the element like 45. Again, not 45, please. In numbers are doing same. Okay, let's look at this scenario. Let's assume that the one element is got deleted. So from the front pointer to the rear pointer, whatever the elements are there, you print them. So I'm going to use a for loop, and you know very well for loop has a counter variable. Generally used counter variable is I. So I'm going to say I starting from front pointer up to the rear pointer. I'm going to print the value. So let's create a variable here. I'm going to say int I. This will be the my counter variable, and let's start the thing now. Before I print it, I'm going to just tell the user that /n elements in the queue. Okay, and let me go to this one. Okay. Let's use a for loop, and I'm going to say for I is equal to front pointer, and I less than or equal to the rear pointer, I plus plus. Okay, and I'm going to print the value of the array. So I'm going to use %d, and then you must put one space here, very very important. Put one space here after the %d, otherwise the numbers will touch each other. Then I'm going to print the value of this one. After this for loop is over, I'm going to use a printf and /n so that the cursor will go to the next line. Otherwise, it won't look nice. So this is done so that the output will look neat. Otherwise, the output won't look neat. Okay, done with it. So let's start with the main now. So let's start with the main. So in the main, what are the things? There are three things you can do. One is you can insert, other one is you can delete, third one is you can display, the fourth one is you can exit. So let me ask the user what is their choice, and I'm going to use the do while loop. So I'm going to say do while the choice is 1 2 3. You can do many things. If the choice is 4, the user wants to quit. So as long as the choice is not 4, the user wants to do something with the queue. So let's start with that. So I'm going to go over here and I'm going to give the menu to the user. So print f. The first choice, let me use /n. The first choice is insert /n. The second choice is delete /n. Third choice is display /n. Fourth choice is exit. Okay, then I'm going to use /n dash 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 and /n. Then I'm going to ask your choice, and I'm going to use one colon here and one space here. Extra space I put here, and then definitely I'm going to put one semicolon there. Okay. After doing this, after adding this, let me use the scanf to accept the choice. What is this one? Percentage. What is happening? Percentage %d. Okay, ampersand choice done. Let's use the switch statement. So switch on the value of ch. There will be many cases. Let's start with the case number 1. Case number 1 is we want to insert. You know very well. Case number 1 is to insert. So how do you call the insert, we will just call the function insert. We have already written this insert function here. So this function we have already written. So we are going to just call that function. So I'm going to say insert and we'll take a break. Let's go to the case number 2. What is the case number 2? Case number 2 is delete, and we have already written a function for deleting an element from the queue. So we are going to say, where is this thing gone? Delete, delete, and done, and we'll take a break. What about the case number 3? Case number 3 is, you know very well, we will go with the display here. So let's go with the display. So that is the case number 3. So we are going to say display. This is the spelling. This is the spelling. DISPLY. I think there is something wrong. Okay, let me complete that one, and let me break this one. Case number 4 is the most favorite one, and that is we are exiting. So we are going to say, let's say /n, and we are saying exiting dash 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 and /n, so that we know that we are going out of this one. And let me take a break here. And the default case when the user types something which is nonsense, so we are going to say printf, and we will say /n wrong choice. Okay, /n, and that's it. Let me remove unnecessary lines here. So this is the extra lines that I have added. So I'm going to just save it. Done. And let me run it. If there is any problem, we're going to see. So if you get like this, you don't know what is the problem. And what are you going to do is you just go here to the view and then select logs, and it's going to say undeclared A. So did I use the capital A? Yeah. Everywhere am I using a small a, so I'm going to just make it as a small a. This I typed it in capital A. No, array, I typed it in capital. I'm going to just make it a small case. Everywhere, because unnecessary you will have to shift and type it. So everywhere where the array is there, I'm going to just make it as small case. Okay, you can do capital also, there is nothing wrong, but you will have to struggle to type this one. Let's go here and let me try one more time. Okay, done. So let's start with an array. So if I simply delete an array, I must get an error message saying that the queue is empty. So am I getting that? So I'm getting the message. So queue is empty because there is nothing. So initially, you know very well, both the front pointer and rear pointer are pointing to this one. Also, if I try to display this by typing 3, if I say display, I must get the queue is empty. Let me insert an element 10 into the queue, and let me display the element by typing 3, and you notice that queue has the element 10. Let me insert one more element. So insert is 1, choice is 1, so I'm going to go with the choice number 1. Insert, and let me insert the number 20. And first let me go here and insert the value 20. Let me display it by typing 3, and 10 and 20 is displayed. Let me insert one more element. I'm going to just press 1 and then type 30. So if I display it by typing 3 here, and you notice that the what is this queue has 3 element. Let me delete one element. I'm going to just type 2 here, and I'm going to get the message saying that 10 is deleted. So this is deleted. So let me show that thing. So you notice that the new queue has 20 and 30. That means 10 has been deleted. Let me delete one more element by typing 2. So you notice that what is this one? The 20 is deleted. So out of the 2 element, only 1 is there. So let me type 3 here just to show you that the leftover is 30. Now I'm going to delete that element itself. What is this one? By typing 2, and you notice that 30 has been deleted. If I press 3 here, the queue is empty now because there is nothing is there. Also, if I try to delete it, and I get the queue is empty. That's all. I'm going to press 4 here to exit. That's all in this exercise. Thank you for your interest. We will meet again in the other exercise. Thank you.